type of office space. So I need to get heat to each one of these rooms, right? I'm going to have my supplier okay, so I have, we'll just assume it's the same in each one of these offices. I have air coming in. Okay, what temperature do you think the air is that I'm supplying?
Right now?
25 degrees.
Minus 20.
No, what if in here? What would be the temperature of the supply air that's coming into this room?
19.
That's a little warm. So we'll go 14 to 16.
Oh, okay.
So when I bring it into the building, I'm gonna do all that treatment, keep it filtered, cleaned, humidified, fresh air, and I'm delivering air that's between 14 and 16 degrees to each room. Now, nobody wants to be that temperature. We want to be warmer, right? So in each duct, I'm going to have a heat exchanger. I'm going to have a heat exchanger. Okay? So generally, we'll say this is to an area, but let's say we spent some extra money and we put a thermostat in each one. The thermostat generally lets you go from 19.5 to 22. So what we're doing is we're heating that air to whatever the thermostat says for that room. And we give people the illusion of controlling the temperature, but really we don't. The heat exchanger is a tube and fin type heat exchanger. So we've got the hot water running through the tubes. The fins themselves provide more surface area, which allows us to either heat or cool that area. Now, right now in the winter, generally we're actually going to be delivering cooler air to the rooms. Why do we want cooler air in the winter and warmer air in the summer?
Comfort.
Comfort, but summer's already hot. So why are we giving them warmer air?
Something to do with the heat exchanger.
Yeah.
No? Oh, humidity. You all said it. No?
Oh. What are you guys wearing right now?
Honestly.
Long sleeves,
Yeah.
sweats, thick socks, right? So you're dressed for being outside in the cold.
Yeah.
Come into a room and you're wearing that much clothes and we're heating it to 22, you're going to be too hot.
Yeah.
So because we wear more clothes in the winter, we supply cooler air to the area. We wear less clothes in the summer, so we supply warmer air. Does that make sense?
Yeah.
Okay. So we have fresh air coming in. We're supplying air that's been treated. We want to make sure our buildings are all positive pressure. The reason for that is we don't want, well, one, energy loss. We don't want our windows and doors to leak, but we want to also make sure that the air that's coming into the building is clean. We don't want it coming in from all these other cracks. So for supplying air, we have to have return air, right? So on this side, we'll do the return air. And our return air is going to be a little bit slower than our supply air, a little bit less pressure. And that's so that we can maintain a positive airflow. All right, so heat exchangers going in. So that means to each one of these supply air ducts, we have to have cooling water and heating water, depending on what it is we're doing for supply. Generally not so much cooling because it's already 19 and we don't tend to get it much cooler. We put thermostats in to give people the illusion of control. Because if you're ever going to be working in a building as a building operator, the most complaints you're going to have is on HVAC. everybody complains, okay? Because you're gonna have one person here with holes, and in the same room, with the same air setting, somebody who's too hot. And each one of them goes to the thermostat and makes those adjustments. Okay, if we allowed that much control to these people, our balance of air would be way off. We'd get too much heat in here, not enough heat in here, and then you got wonky things happening with your air supply. So air going in, air going out. Okay. So what's going to happen is the air is going to blow in. Typically we have return air and supply air in the same area, but we have one of these newfangled washrooms that don't have doors on them. They just have those walls. Okay? If we don't balance this air properly, what's going to happen? The odors from here are going to travel into where your exhaust is, right? So we have to make sure that we have a supply duct here. So we're going to have a supply air duct going down this column, and we're going to have a return air duct over here. And that's going to help make sure that we're not drawing in those odors from another area. That make sense?
Yeah.
Okay. So comfort parameters are oxygen, and along with that, carbon dioxide. Temperature, humidity, and we also filter for particulate. We know that if there isn't enough oxygen in the room, based on capacity and based on size, generally you're looking at about 5 air changes per hour. That's about standard. If we're not getting enough air supplied, fresh air supplied to the area, people are going to start to get sleepy. Because the more carbon dioxide you have, the more tired you get. Most of these systems are based on your CO2 levels, starting around here and then slowly building over the day, and then 6 o'clock. Okay? So ASHRAE is the group responsible for HVAC systems. Figuring out how many people, figuring out where all your ducting is going to be, that sort of thing. And whenever you make a change, you always have to bring somebody in to balance the air. You can always tell a building when you're in balance because you're pushing to get a door open that is under positive pressure, or you're pulling too hard, or you've got the whistling under the doors, or odors are building up. We have to make sure that this buildup of carbon dioxide goes up a nice gentle slope. And by the time everybody gets home, it drops off. It's pretty good. If we don't have that exchange, we're not bringing that oxygen, again, we're going to have sleep tired. But we also know that people perform poorly with less oxygen. By enriching the amount of oxygen that people are breathing, we're going to get them to perform better, they're going to have more energy. That's why the casinos always have oxygen, extra oxygen pumping into them, so you've got extra energy to sit there and play all night. We did a study where they had students writing final exams in a room where they put in extra oxygen. They all did better. Well, we know that it's not just the comfort, but it's also all function. So temperature, like I said, we're supplying it between 14 to 16 degrees, and then the heat exchangers are going to bump it up to whatever is general for that room. Humidity. What is the problem if the humidity is too low?
Well, it dries everything else in the building.
Static.
Static, yeah. Your mucous membranes start to get irritated, right? So people get itchy, sore eyes, their nose gets really dry, their throat gets really dry. And then if the humidity is too high, then we have condensation, people feel too warm because warm air holds more moisture than cooler air, right? And it starts to particulate. We're filtering out all the chunks. Now you notice we're not actually killing any bacteria or eliminating smells. We're just filtering the air. If we wanted to eliminate bacteria and smells, we would probably have charcoal filters. You wouldn't have a recirculation of your air. It would be 100% supply air. Because your return air goes back to your system. And we have this long train with all these extra rooms. And we're going to have an area here where we get some return air. And then some of the air goes to exhaust. Okay, so outside air coming in, supply air to the rooms, return air going back to your HVAC, and then if we have 100% exhaust air, we're constantly bringing in 100% outside air. It's costing us a lot of money, right?
Yeah.
Because we're paying to heat it, humidify it, and clean it. The filters have to be replaced. But very rarely will you work with place unless it's like a hospital or a research center where you have to have 100% outside filtered air, outside air, and then they add those extra filters to clean it with. Okay, does that kind of make sense? All right, well, let's take a look.
There's one of those thingies over here.
Yeah, I'm just trying to think where I should start. Let's start with supply air. Okay, so supply air is coming in this big white thing here.
Yeah.
And we're going to follow it.
My air.
All the way over here. Somebody flip the light switch there at the end, please.
What's the white?
Just on the wall there. Just flip the light switch on. All right. So this is our supply air, our outside air. Brings in the fresh air. On the other side, there's a round silver duct that comes in, and this is our return air duct. Okay. Now, generally, you're not going to find a return air, any ducting with a 90-degree bend on it. One, it makes a lot of noise, and two, you're changing the flow of the air. It's going to take more energy. But they built it this way. Okay, so here we have baffles. And the baffles are going to take the airflow coming this way, and they're going to change the airflow, and the air is going to come into this space here, where we have our forced draft fan. Okay? Baffles don't move. They're fixed in position. Dampers are the ones that move. Okay? So it brings the air in here, and from here it goes through the fan and into this area here. Now we have, this is kind of called the economizer, right? So we can either open this area here and send 100% of the air up outside the building as exhaust air, or we can keep that closed and have 100% of the outside air come in as supply air. And any percentage of mixing between those. So we can go 100 to 0, we can go 50 to 50, we can adjust it so we maximize it, right? In the winter, we're spending a lot of money to heat the air. We're going to return a lot of the return air and use it as supply air. So this is our mixing chamber where we start to get all of our exhaust air and outside air mixed up together. Okay, we also have fresh air dampers, so we've got more air coming in here. We're going to go through our first layer of filters. Mostly your filters are going to be cloth filters. Some of them may have a little sticky thing that the particulate sticks to. But you're gonna have a big outside filter anyway, so that we don't get feathers and birds and sticks and leaves and whatnot in anyway. So this is really considered second stage filter. We have pressure before the filter, and we have pressure after the filter. Okay, so now we know how much airflow is coming through our filters, gives us an idea of how often they need to be changed. Okay, generally, if you're going to work at a place, they already have kind of a schedule. They know it's going to take every 4 months we have to replace them, that sort of thing. But we're also going to make sure that, you know, during the summer when we had all that extra smoke, we had all that extra particulate. So the filters were plugging up a lot faster than what you would normally expect. So that's why we look at our pre and post filter. So far we've brought in the outside air. It's minus 19 out there right now. We're going to hit our first set of coils. So if I have water in these coils and that cold air comes in, what's going to happen?
Or freeze.
It's going to freeze, right. So I may have to preheat that air.
Yeah.
This is a mixture of glycol and water. So your first is always going to be glycol. We don't want it to freeze. And it's going to make sure that it gets to a minimum of 4 degrees. In here I have these wires. Those wires help with temperature. Okay, it tells me what the temperature is of the incoming air. Based on that temperature, the computer's going to say we need more glycol circulating, we need less because it's summertime. I also have this little piece of metal hanging down there in the middle of that filter. What do you think that is?
It's a pressure sensor.
Pressure sensor. What type of pressure sensor? Not really pressure, it's a flow.
Flow, yeah.
It's a flow sensor.
Flow sensor.
What's it measure the flow of?
Yeah.
Air.
Air.
Yeah.
Okay, so what kind of air pressure, airflow sensor would that one be called?
Is it pitot tube?
Pitot tube. Right.
What is
Just
it?
like a pitot tube.
Never heard of that.
Same as what the airplane uses.
Airplane, yeah.
P-I-T-O-T.
Pitot.
Okay. So now we know we've got enough air coming through. We know the temperature of the air. We're going to either preheat that air or we're not. So this is only first level for heating. Then we have a temperature gauge on the next set. Okay? Tells me what the temperature of the air after it's come through the heat exchanger. And you can see that it's a tube and fin. Right? That's the most efficient that you're going to find for any type of HVAC systems. Okay, then we're going to go through our next filter. These are box filters, or bag filters in a box. They're quite deep. And as you can see, people keep touching them, but as you can see, there's little neat kind of like tin foil, basically. Fins that are coming off. And what that does is it holds the bags open. Because the filter is this long, we want the whole thing to be able to capture any particulate in the air. So these are the box filters.
Really, would it be called like, is it something like biocell or it's different from a biocell?
Biocell would be for purification and killing bacteria.
Okay.
We're just taking particulate out.
Okay.
Yeah, so smell, gases are not particulate. So if we
This is more like a bag filter, would you say?
bag filter, yeah.
Bag filter?
Yeah.
Okay.
They're just in a box.
Okay.
So if you got a manure plant beside you, you're bringing manure smell, not as bad, but
Okay.
you're still getting the smell in, right?
Yeah.
This next coil here is for heating. We're using steam to heat the air. So before we do that, we need to determine we have to heat the air or not. If it's summertime, I don't want to heat the air.
Yeah.
So if you look here, I've got a bypass dampers, or I can take that air and bypass the heating or the steam coil. So we're not heating air that's already hot.
Yeah.
If I do need to heat the air, I've got this here, the the dampers are below, I would close the bypass. We would run it past the steam. As you can see, there's another heat exchanger on this side. And then on this side, we've got a thermostat. Again, how hot did we heat that air now? What's the temperature of the air running through our system at this point? I have a blue thing there. Kind of looks like Thor's hammer. What is that? Measures our humidity, right? So we know air at different temperatures can hold different amounts of water. So we're going to detect the humidity. Passes through this heating coil where we have hot water in case we have to heat the air a little bit more. Again, we've got the temperature coil there. And then on this side, we've got another tube. Now what if it is summertime? We don't want to heat. We don't have to have the cool water on, or hot water on, but then we would use the cold water. Cold water for cooling. And we're going to actually cool the air to a specific temperature where we know how much humidity is in the air. Okay? Because we can only give 100% humidity or 0% humidity. So we know that air temperature at this temperature, what is it, 8 or 9 degrees, so we actually cool it right down to the dew point. That way when we humidify it, it works out to the percentage that we want. So here we have our humidity. So we have basically steam going into those pipes. The pipes have little holes in them. It jets out the steam. And as the air passes through that, it humidifies the air.
Not many places got that, I'd say. Not many places got that, I'd say.
No, well, or it's just not working very well.
Yeah.
From there, we've got the fan that sends the air up into our supply. Okay? So we have outside air. Supply air is what we're putting in the building. Return air is what's coming from the building. Exhaust air is what we're throwing outside. Now let's look at what each of these rooms have. So up here, we have 4 areas. We have 4 zones. Each zone has its own thermostat. But if we look up, you see those flat boxes?
Yeah.
And it says EA. Exhaust air, or return air, okay? So at the end here, it's solid. And we've got the vent on the top that the air is being drawn in, and it's going into our return air. Okay, so there's nothing special about those. There's some filters in there, there's some noise canceling stuff in there. That's what's taking out of the room and returning it back to our system. So look over here. You see our supply air. So our supply air branches off, and you can see the first piece of ducting has the heat exchanger in it. So you can see the copper coils coming out the outside. So to that heat exchanger, we have hot water running. And the amount of hot water running through that heat exchanger is going to be based on what we set the thermostat for this zone. So it's coming to that spot there between 14 and 16 degrees. That's where it heats up to the temperature where it's designated for the zone. Make sense?
Yeah.
I was a bit confused. Why the arrows facing the opposite direction? For the supply arrows facing outwards. For the exhaust, the arrows facing.
Yeah, that's right. Because the supplier is coming from that last
From the
fan.
header there. Okay.
Yeah, from the white, big
Yeah.
round white thing. It's coming out from there into this zone.
That is a
And
zone.
that's our fresh air supply for the zone. But we have to have the return air, right? And because we want to be positive pressure, our return air is going to be, our exhaust air is going to be a little bit less
Yes.
than what our supply air is going to be. So you can see the ducts are a little bit smaller. And that's HVAC.
That's it, right on.
That's it. That's all there is.
Ah. What those pipe? They are the same like this one?
That's the exhaust.
How about the other side? Are they the same? Yeah.
They each have their own little.
Oh, I see.
But there's ones that like in hotels they got like the wall unit thing too.
Right, but that's not air ventilation. That's heating.
Heating, yeah. Heating.
So the same thing. They're going to be hooked up to hot water, and whatever temperature you set it at is going to.
But some of them are like AC heating, like they're that combo unit, right?
Yeah, but that's so we'll talk about refrigeration.
Oh, that's the part of the whole
But
refrigeration.
the whole room, the supply of fresh air to that room and the exhaust from that room, that's what we're talking about here. So the big system.
See, because like our camp, it's super dry. That's what made me. I was like, they don't add that to every system. That's for sure. Like in your bed, it's all sparks. But like it almost seems like we just get a constant feed of the exact same air, and then our combo unit will give us extra heat if we want. You know what I mean?
So then again, that's not warm. Some people are warmer than
Yeah,
some people are
and that's
colder.
why they
The
do that, I
same-
guess.
Yeah. So you have your control with
Yeah.
your own unit. That way you're not affecting.
Right, yeah.
everybody
Yeah,
else's
yeah.
air.
Individual.
Cool.
All right.
Cool.